Good morning, all of you. In today's class, we'll be covering software. That is one of the topics in Unit 1. The objective of today's class is to understand what a software is. What are the different types of software that we have? That's our application software and system software. And mainly we'll be discussing about one of the system softwares, that is our operating system. So we'll be understanding what an operating system is, what is the need of an operating system, and what are the different functions, or we can say operations, of an operating system are. So let's start with what a software is. A software is a set of programs. We can say it is a step-by-step instruction that tells computer how to process the data. We already know that a computer, the work of a computer is, it's a machine that takes input as a data, processes it and gives us an output. So software is the one that basically helps us in doing these processing, right? Our software can be divided into two types: application software and your system software. A system software can be an operating system, it can be a system support software, or it can be also a system development software. Whereas when we talk about application softwares, they are either general purpose or application specific. So let's pick them one by one and let me explain you what a system software is first. System software is a type of computer program that is designed to run a computer's hardware and application programs. Now, when we talk about a system software, that's basically an interface between a user and a hardware. Your operating system is a layered structure. Now, when we say layered structure, what is the meaning of that? That means every layer works as a separate entity, have their own set of work associated to it. When we talk about system software, when we talk about the software itself or the computer system itself, the innermost layer is your hardware and the outermost layer is your user. So if user wants to communicate with the hardware, then they need some intermediate between them. That interface between the hardware and the user is your system software. The best example of a system software is your operating system. Operating system is the one that manages everything in your computer. Whatever you are doing in your computer, that is being managed by your operating system. The other system softwares are your translators, which we are going to do in the next class. That's your compiler, that is your interpreter, assembler. All these are also part of system softwares. After system software comes your application software. Application software is commonly defined as a program or a set of programs which are designed specifically according to the requirements of an end user. That means whatever the end user wants, every user that we have for a computer may have a different kind of requirements. They have different likings. Someone may like a video. Some other person may like to listen to a music. So for one person there is going to be a video editor, for the other person there is going to be a audio editor, or let's say a music app. So every user has a different set of requirements, and for different set of requirements we have different application softwares. People often use the term application software to talk about the bundle or group of individual software applications. Okay. Now application software is further categorized into two types: a utility software and an integrated software. Now, what do you mean by a utility software? When your application software is doing only one kind of task, then it becomes a utility software. This could include firewall. It can be WinZip, WinRAR, the softwares that we use. It can be an antivirus application. Okay, it can be a defragmenter tool. I hope you have used all these things. Firewall is for security, antivirus is also for security. Zip is your WinRAR, and WinZip is for compressing the files. And then comes your defragmenting tools, which is basically used to move all the free space together, right? That's what your utility software is. Then comes your integrated softwares. Integrated softwares are the softwares that normally does more than one thing. It's basically a bundle of application. So your MS Office is integrated software. Your Adobe Acrobat Reader is there, PDF is there. There are so many other things. Editing editor is there. That is your integrated software. Your database applications are integrated softwares. So when it is one kind of work, then it becomes a utility software. When it is bundle, it's a combination of more than one uh, kind, then it becomes your integrated software. As I was saying that your operating system is a layered architecture, you can see over here that in this case, you can see here, hardware is the innermost layer. Your hardware is the innermost layer. Then comes the layer of a system software. Without system software, we cannot have an application software. And the last layer is your user. So operating system layer basically hides the details of the hardware from the programmer and provides the programmer a convenient way to use the system. That is what is the work of your system software is. Now let's talk about what an operating system is. As I said, that your operating system is the most important system software. A program that acts as an intermediary between user and the computer hardware is your operating system. So basically, whatever is the definition of a system software, the same is the definition of an operating system. Why do we need operating system? That's again another important thing. The goals of an operating system are to execute user programs and make solving user problems easier. So basically, the first work is problem solving. Second work is to make the computer system convenient to use. It will be easier for us to use our operating system if we have our computer if we are using an operating system. And the last one is efficient usage of the hardware. That's another work of an operating system. Now, what does operating system do? It depends on the point of view. User want convenience, that's the ease of use. But user is not bothered about resource utilization. Now, when we say resource utilization, you'll ask me what a resource is. Anything in a computer is a resource. Your memory is a resource. Your CPU is a resource. Your input and output devices are a resource. So anything in a computer system is basically a resource. When we talk about user, for example, you and me, we are not bothered whether the resources are being utilized in an optimized way or not. We are only bothered about one thing, that's the ease of use, whether it is easy for us to use or not. But when we talk about shared computers, I'm not talking about a normal PC. This is a PC, right? For a single user, meant for a single user. But when you go to the company, you'll be using mainframes. You'll be using many computers. They may be sharing resources. So probably the similar same place or the same memory may be shared among thousands of employees. In that case, now what happens in this case is there is one server and there are many workstations. All workstations are accessing the server. That means they are accessing the resources of the server, which is a shared resource. Now, in this case, resource utilization becomes very, very, very important. Because if only one person will be using all the resources, then your system will be, resources will be wasted. Others may not get it, though they are authorized to get it. In that case, what does an operating system do? The most important work now we can say for operating system is to utilize resources in such a way that everybody will get a chance to access a shared resource. So, operating system is a resource allocator. It manages all the resources, and as I said, resources, anything in a computer is a resource. CPU, input, output devices, memory, all these are resources. Also, it decides between conflicting requests for efficient and fair resource usage. There may be a possibility I am requesting and you are requesting for the same thing, but they have limited resources associated with it. So, which one will get the resource first? Probably the one with the higher priority will get the resource first, right? Now, another work of an operating system is it's a control program. So, what it does is it controls executions of program to prevent errors and improper use of computer. There's a part of operating system, the moment we switch on our system, that goes to the memory. That's here. We have started about RAM and ROM. So basically one program that is running all the time and something that is running all the time needs to reside in RAM, random access memory. So that needs to one program that needs to be running all the time in the computer is known as kernel. Now, what are the operations of an operating system? Let's talk about operations of an operating system. The first one and the most important one is your process management. Now, what do you mean by a process? A process is a program under execution. Now, when we say program, that becomes a passive entity, and when so it talks about a process, it becomes an active entity. When we talk about process, why it is active? Because it needs CPU, it needs memory, it needs input-output files, it needs initialization of data. So it becomes an active entity, right? So once the process terminates, then it needs to assign or it needs to, once the process gets terminated, all the resources that has been used by the process are released. Now, when we talk about process management, what are the activities that are connected to process management? The activities are creating and deleting both user and system processes, suspending and resuming processes, providing mechanics for process synchronization, providing mechanisms for process communication, and for deadlock handling. Now, what do you mean by deadlock handling over here? Deadlock handling means, for example, if two processes are fighting for the same resource, then they must be allowed to access only the one that is allowed to access the resource must complete its work in a finite time and must not go under a continuous loop. If it goes under a continuous loop, it becomes a deadlock. This is what is your deadlock handling is. So these are the different activities that we have for process management. Next activity or next operation of an operating system is memory management. All the data in the memory before and after processing is being managed by memory management. All instructions in the memory and the order in which they will be executed is also handled by this unit. So memory management determines what is in the memory, okay, and how can it optimize the utilization of CPU. So it basically keeps track of everything related to the memory, which is a free location, which is not, whether to allocate a space or not to allocate a space to a process, deciding which process is going to get the CPU, right? All these things, where to which process is going to get the, uh, a particular memory location. All these are done by memory management. Next comes storage management. Now, when we talk about storage management, what it does is OS provides a uniform logical view of information storage. Now, when we talk about how it stores data on a hard disk or a secondary, here we are talking about secondary storage management. It has a file with the help of which it can store data on the secondary storage, or we can say hard disk, a permanent storage device. Okay. Now it also needs to take care of the properties like access speed, what is the capacity, what is the data transfer rate, what is the access method, whether it needs to be a sequential access or it needs to be random access. All these things are taken into consideration while doing storage management. Once the files are stored, then we need to manage those files. So then comes your file system management in picture. Now, when we talk about file, your file is usually organized into directories, right? So, what are the access control? What are the access rights? How to create a file? How to delete a file? Okay, how to manipulate the file? How to map files onto secondary storage? How to take a backup of file? All these things comes under file system management. Next comes your mass storage management. Now, this is again similar to your storage management. Usually, disk is used to store data that do not fit in the main memory or data that needs to be kept for a long period of time. We also need to take care of these disks. So when we talk about storage management, it is basically divided into two types. One is your file system management, another one is your mass storage management. So we just talked about file system, now we'll be talking about mass storage. Now any activity related to your disk comes under mass storage management. Okay, so the entire speed of the computer operation hinges on disk subsystem and its algorithm. So what are the different activities that are associated by mass storage by the operating system for mass storage management? These are free space management, storage allocation, disk scheduling, right? All these comes under mass storage. Fine. Then comes your input output devices. Every hardware in the computer system is being managed by your operating system. Input output devices are also in hardware. So, what are the responsibilities of operating system for IO, input output devices? Memory management of input output, including buffering. Every input output device has a buffer associated to it. Whenever you click on a printer, whenever you try to take a printout, supposedly you have given 100 pages. Even if you close the document, still the printer prints the data. How it does that? It stores all the pages that you have given for printing in its buffer. Buffer is a limited storage area. So it keeps on printing and clearing the buffer, right? So it's a temporary storage area. Fine. It also does caching. Caching is basically for faster data transfer, right? Then it also does spooling. Spooling is basically overlapping of output of one job with input of other job. So basically it is combining, doing it in batches, right? So all these are handled by input output devices. All the device driver interfaces are being handled by IO subsystem. So these are the ones which are this is another operation of your input output subsystem. Then comes your protection and security. Operating system is the one that controls, that basically provides protection and security. Any mechanism for controlling the access of the processes or users to resources is basically defined by your operating system. Also, supposedly, there is some kind of attack on an operating system. Then the defense system is again done with the help of operating system. Your denial of service attacks, worms, viruses, identity thefts, thefts of services, all these are being handled by operating system up to some level. We may not say that it does a lot of work associated to it, but yes, for some up to some level, this is being handled by the operating system. So what all it does, it identifies the user, okay? It basically gives a user ID and a security ID to a user. User ID then associated with all the files. It also decides which particular file will get which user ID, right? Then it decides the group identifier. It allows users to identify and the controls to be managed. Okay, and then privilege escalation allows user to change effective IDs and have more rights. So all these things are done by your operating system. There are many such tasks that we are doing with operating system. So let's summarize it all. We have talked about two kinds of softwares today, application software and your system software, where we have specifically talked about the different types of operating system as a type of a system software. We already know the work of an operating system or the operations of an operating system is it's a resource allocator, right? And it is a control unit. Basically, the work of an operating system is to optimize the resources and to be an interface between hardware and the user. The different operations are your process management, memory management, file management, disk management, your protection and security. All these comes under your operating system. So that's it for today. If you have any questions, you may contact on the ID that is given on your screen. Thank you so much. Thank you.